Hi students, welcome to lecture online. In this session, we'll introduce you to a new type of follower. Before that, we'll try to recall what we have learned earlier, the different types of followers. So what we have learned earlier is a knife edge follower and a roller follower and a flat face follower. So all these three types of followers have an axis of reciprocation which is along this. These are due to the cam which comes in contact like this at each of these points, and they make this cam rotate. The rotation of the cam is now converted into the reciprocation of each of these followers. Now let us see what is an oscillating follower. Oscillating follower, as the name indicates, does not reciprocate. It actually oscillates. So for that it needs an inch, and in simple way you can assume this to be a lever type mechanism which has got hinged here, and this oscillates, and the motion from a cam can be transferred directly into this through a flat face, or it could be transmitted through a roller. So in our syllabus and in most of the engineering colleges syllabus, we have the roller attached to the end of the oscillating follower, and here you see that each time a cam revolves like this, the oscillating follower would be lifted by this much. So the oscillating follower would be lifted through an angle here. So here you will see that here they would not give you the height of this, but they would give you the angle through which this oscillating follower would reach a new position from the lowest position. So if this is theta, so then if you want to know what is the extreme other position of the lever, then you should actually call it as h sine theta, assuming that these oscillate. Now the oscillations which actually go like this from here to here with theta, so this could be assumed as in the opposite side h, and this can be assumed as the lever length L. So in that way, if you want the h value, so h by L is sine theta. So if you want h is equal to L into sine theta. So if the values of the lever length and the angle through which this oscillating follower, which is basically a lever, has to move, that is this angle, and this is given, then you can find out h, which will be later used for drawing a follower displacement diagram. When compared to other type of followers, oscillating follower numericals have three unique data. The first data is the length of the lever, and then of course it has a roller with a roller radius, and then this is driven by a cam which has a base circle which is equal to this, and of course it will have some sort of a lift which this has to generate to produce an angle like this. And to locate this point, we should know the distance from the center of the base circle to this point. So this is called as the distance between the pivot point and the center of the cam. So therefore, in a numerical, so if all these data are given, like the base circle radius is given, the roller radius is given, the lever length is given, then you can actually locate the pivot point. You can locate the pivot point this way. So first what you need to do is you need to draw a base circle. The center of the base circle is this, and then draw a vertical line, and then again draw a roller with the specified roller radius, and then since you know the length of the distance between the pivot point and the base circle center, with that distance you cut an arc. That means you measure the distance, through that's with the compass, and then you try to cut an arc, and again you know the lever length here. So you know the lever length, which is equal to this. So from this point you try to cut an arc like this. So these two arcs cut here. So this is the lever. So this is the pivot for the lever point, and this is the distance. So this is how you start a problem in the case of a oscillating follower. Let us now solve a numerical, and you need a data. Let us see the possible type of data here. When we say the type of follower here, there could be 4 types: knife edge, roller, flat faced, and the oscillating follower. So we will choose the oscillating follower, which we have not done. So the type of follower is the oscillating follower. And now the follower here has to move outward and also inward, and these are given in terms of the angle. Here the follower would move outward when the cam rotates through an angle of 20 degree is mentioned here, and of course the cam would rotate by an angle of 120 degree, and the oscillating follower would lift through an angle of 20 degree. And the way this has to be lifted, you can have 4 options here: uniform velocity, simple harmonic motion, uniform retardation motion, acceleration and retardation motion, cycloidal, like this. And similarly for the follower to return. So here let us make the problem simple. So let us take the follower to move outward through 120 degree, and also the return through 120 degree, and both, once it moves outward through 20 degree outwards, then it has to return through 20 degree inwards. We are speaking about the lever, that is the oscillating lever. Let the other required data are the length of the oscillating lever, and let this be 70 mm. So let me write this here, 70 mm. The distance between the pivot and the center of the base circle, let us take it as 80 mm. And then the base circle radius has 30 mm, and roller radius has 10 mm. So with this data, let us start to solve the problem. Before that, to know the distance through which the roller has to be lifted, we have to first draw a line with the length of the lever, and then we should draw a line at an angle of 20 degree, which is equal to the length of this roller, that is 70. And of course you need not have to do this as per geometry, because we are trying to solve this with calculator. Now we know that the roller shifts from ear to ear, so therefore the vertical height which is actually displaced during this lever movement of 20 degree is nothing but h is equal to L, which is the lever length, into sine 20 degree. So let us now find, so this is 70 mm into sine 20 degree is equal to 23.94, which I will take it as 24 mm. So with this data, we'll start to draw the follower displacement diagram. We just now found that the height of the follower displacement should be 24 mm. So let us draw a vertical line which is 24 mm and then draw a rectangle like this. So let us take the first part, which is actually the ascent. Then node dwell is given in the problem, then there's directly descent. So for the next, so they directly have ascent and the descent here. So this is the ascent part, this is the descent part. And for the ease of the problem, let us assume that out of this data let us assume that the ascent is also UV, descent is also UV, which makes my construction easier here, because all this was taught to you earlier, how to actually construct for cycloidal and UARM, so it should not be a problem. So here, let us now divide this into 6 parts. Like this. The follower displacement diagram has only 2 parts. That is the follower ascent, which is actually phi a, which is through an angle of 120 degree, and we have seen that this height is 24 mm, and we have constructed as per this. And the follower rises through uniform velocity, so I am trying to draw a line. And if it was simple harmonic motion, then a semicircle here, and then dividing it by 6 parts and naming it so on. And similarly for cycloidal and for UARM, you need to follow the procedure. So this is the follower ascent. Then we have got the follower descent again through 120 degrees of the camera revolution. So node dwell in between. So this descends. So basically, there are actually 6 positions in between 0 degree and 120 degree. So let me name these positions as 1, 2, 3, 4, 5, 6, and this will continue this as 4, 5, 4, 3, 2, 1 and 0. Now I marked the locations 1 dash, 2 dash, 3 dash, like this up to 1 dash. So these are the heights through which the follower has to rise after every 20 degree, so that by this point it rises by 120 degree. That's at 120 degree it rises through this side, and again the next 120 degree it comes back to its original position. Now let us see how now we'll draw the base circle, which is equal to 30 mm, like this. And then let us draw the roller radius, which is equal to 10 mm, which is here, like this. So the roller and the base circle are now drawn. So knowing these 2 centers, then we need to locate the point at which the oscillating lever is pivoted. So as per the data, the oscillating lever length is 70 mm. So I'll take 70 here, and then keeping the roller, I draw an arc like this, and then it is given that from the center of the base circle to the pivot it is 80 mm. So I'll keep the compass here and then draw an arc here. So this locates the pivot point. So the pivot is here like this. The pivot initially is here like this with the roller, and this is the base circle of the cam. This refers to the starting position, which is at 0, where this roller is not lifted at all. So I should call this as the point 0. Now to locate the other points like 1 2 3 4 5 on the base circle. So we should start at this point, which is the 0 point, and then mark the angles for each of these degrees, like 0, from 0, 20, 40, 60, 80, because here this 120 degree is divided into 6 parts, so each of this is actually 20 degree. So I located these points. So once I have done this, then on the base circle, then I can locate these points here. So don't have to draw the radial lines. You just have to draw, keep the scale like this to locate these points. So of course, before locating this, here I have made a small mistake. So the mistake is the locations of the 0, 1 to 5 are not on this base circle, because for a roller follower, the trace point is not this point, the trace point is this point, because the cam can come in contact with any of the roller points here on the periphery. So what we should do is we should draw a circle passing through this, which is called as the prime circle. So each of the lines drawn for 20 degree where it cuts the prime circle. So let me call this as starting point as 1, this point as, this is 0, this point as 1, and the next point where it cut it 40 degree as 2, like this. All these are marked on the prime circle like this.